Dr. Roshan Tiwari. He'll be speaking on conservation of conscious experience, a quantum information approach. Dr. Roshan Tiwari has earned his MS and PhD in physics from IISER Kolkata in 2023. He is a B.Sc from Banaras Hindu University, and his doctoral research spanned spectroscopy, bioinspired microwave guides. He is currently the research scientist at Bhaktivedanta Institute, Kolkata.
So I'm very happy to present my work I was doing to all the people here. So as the topic you can see, it's about conservation of conscious experience. And the approach I'm using is the work which I have did with Professor Anupati, whatever small thing I'm doing. It's a very humble start I have made in this area. So my topic, as you see, the content of my topic would be about conscious experience, and that is called qualia. It's a basic unit of conscious experience, and some of the properties of qualia is unobservability, uncommunicability, because we cannot observe our qualia, our conscious experience. A third person cannot observe it. Similarly, we cannot communicate what we experience, and there are some limitations of classical physics to explain these areas. And we will try to use quantum theory as a rescue for this problem. And I will also introduce some of the inner privacy and quantum the map between this, and I will use no cloning theorem. And lastly, I will use the conscious conservation of conscious experience by using this no hiding theorem from quantum information approach. So we all know that there are two aspects of reality. The first one is the objective reality, and third is subjective reality, which we cannot ignore the subjective reality. Objective reality, as we can see, there are cosmos, there are laws, the observable universe, there is observability, determinism, and which are governed by classical laws. They are symbolic in nature. At the same time, there are some of the realities which are inner reality, subjective reality, which a human being or any other conscious person or animal have. That is the conscious experience, and that the property of that is unobservability, non-determinism, and it cannot be explained by classical laws. And it is semantics in nature. It has an inner meaning. It is not symbolic. So the experiences, the basic unit of this experience are qualia, and they are subjective as they are subjective aspects. For example, redness of apple could be different for two different people. The intensity of redness. So some of the examples of this thing is the experience of, for example, tasting chocolate. When we taste chocolate, we get some experience, right? Similarly, if we are smelling perfume, we get some experience. Similarly, headache, someone has a headache. So there is a connection of this experience, and this is a fact which we cannot neglect it. It is in our daily day-to-day life that we are experiencing these things, but we don't pay much attention to that. What is this? What is the scientific approach we need to use to explain these things? So that is very, very relevant, because all this beauty in the entire cosmos, all this feeling of awe and reverence because of these experiences, right? So we need to pay attention to these things also, not just the mechanistic and the outer objective things. Subjective thing is also as important, because all the problems in this in the world, because of these subjective things, the love, the pain, and we need to pay some attention to that. So I will try to explain it one by one. The properties of qualia is the unobservability. We cannot observe it. A third person cannot observe what I'm experiencing, right? What I'm going through. Some information he can get by reading my face. By reading my face, he can get some information, but what I'm going through, outer person cannot understand or cannot relate much. What I'm Similarly, it is uncommunicable, difficult to share with others. Experiences could not be converted into communicable classical information. It cannot be converted into bits, 0 and 1. Similarly, it cannot be copied and pasted. For example, if I want to share some data with you, I can just copy and paste it. It is a binary data. But when it comes to our own experience, we cannot just copy and paste it. So there is a limitation which is somewhat imposed by nature. Yeah, so we need to, I will go into this detail. For example, a person is eating some ice cream, and a surgeon is there who just cut his head, just a hypothetical situation. After cutting his head, and he's doing some MRI scan of his brain, what he founds that there is a signal of when he's eating ice cream, that ice cream is going to his tongue, and it is getting converted into electrical signal, then going into brain. So that thing he can see in the MRI scan or any other tools. But now the question is, can the doctor understands or taste what he's eating? Can a doctor, the surgeon, can know what the taste of that ice cream? No, because that remains, the very, very, secret thing, the private thing for that person. So the signal which he is getting is a classical data, MRI scan. Then that MRI scan could be converted into digital data. By computer, you can plot the data, but what that person has experienced, it is out of, out of knowledge. It cannot be accessed. So the physiological brain activity due to electrical excitations of neural networks is observable, but the experience is unobservable. So limitations. So the qualia property cannot be explained by classical physics. It requires a new theory, and quantum physics or quantum information may explain. I'm not saying that it can explain. It may explain, may give us some hint about the inner privacy of our conscious experience. So I will just give a brief note of what this quantum information is, because we all know we are having so much lectures on quantum information, quantum data, foundations of quantum physics. So we all know about bits, right? 0 and 1, classical bits, because all these mobile phones are run on these bits. But what about these qubits? Qubits is the basic unit of quantum information. And you see here, you can see there is 0, 1, 0, 1, and it is in superposed state. It is superposition of 0 and 1. But when you go to classical bits, is either 0 or 1. So qubit can exist in the continuum of states between 0 and 1. And it is unobservable. As soon as you go into measure, it will collapse into one of the possible states. So this superposition is unobservable. And it follows linearity, superposition. So for example, there is a qubit, this is a Bloch sphere, and any given state vector can be represented as the superposition of the 0 and 1, the basis sets. So that's why this qubits is in a superposition state, whereas these bits are in discrete states. So as I already explained, that measurement of qubit leads to collapse of the superpositions, giving rise to classical information. So whatever classical information we are seeing, it's a collapse. Because because quantum information is more subtler, as soon as you measure it, it's going to collapse. And this is because of this collapsing, it averages out all the possibilities of quantum information, and because of this, classicality arises. So classicality is more grosser than this quantum stuff. So there are theorems in quantum information, which is very much similar. I'm just drawing the line between them, that quantum information similar to our experiences maintain its privacy and its unknowability. Quantum information theorem says, which is the no cloning theorem, it says that we cannot make copy of an unknown quantum state. We cannot, it's a limit on quantum information that we not copy and paste quantum information. Similarly, there is a theorem called Helvaux theorem, which says that there is always an upper bound to the amount of information that can be known about a quantum state. We have a limit of what amount of data or quantum information we can have the information. We cannot never understand the complete data about any quantum information. There will always remain a limit on that. So this is what this says. So for 1 qubit data, you can only access 1 bit of data. So there are recent work done by some of the physicists in this area, because internationally there are few groups who are taking much interest in these areas nowadays. And D. Arion is one of them. He is also collaborating with Fagin, who built the first microprocessor. So they are collaborating and coming up with some of the theories, and they are proposing that qualia, the conscious experience, have all the essential properties of pure quantum states. And qualia is private, unclonable knowledge, only minimally knowledge from outside. They can be minimally knowable from outside. So there is a limit. And he's also asserting that superposition and entanglement generate high level qualia or thoughts. For example, in our brain, we have so many thoughts coming simultaneously, and there is synchronization of neural activity happening. So they are proposing that because in our brain also, the superposition and entanglement might going on. Because of that, it is giving rise to high level qualia, high level thoughts. Because we can see sometimes in the dreams also two different things. We have never seen golden mountain. We have just seen gold and mountain, and in our dreams we see golden mountain. It just get combined. How that thing is arising? So classical theory is not able to explain. So that's why they are proposing that quantum phenomena might play a role in our mental world. And so this is just a diagram where two different colors combine, giving third different color. So that might be similar to like our two or four thoughts getting combined to give different thoughts and experience. So there is another book called Quantum Information and Consciousness by Danko Gorgi. He has also written this nice book. If anybody is interested, they can go through this book. It has a lot of information. He also have wrote a paper which says inner privacy of conscious experience and quantum information. So I have also got inspired from this work in my presentation. And there is another guy, this Ariano has written hard problem and free will and information theoretical approach. So any information theoretician can consult this work because he's introducing that the hard problem of consciousness, that how this consciousness arrives, how this conscious experience arises, is a hard problem. So these guys are trying to, understand, exploring the ways how to understand these things. Similarly, there are many works going in nowadays. Similar, just 2-3 years, you can see a number of papers have come on these areas. And even Google also taking interest in this. Professor Hartman Neven has written this paper in just previous year, testing the conjecture that quantum processes create conscious experiences. And they are trying to, even make some robots, conscious robots, and using some quantum information, quantum process. And according to them, they are saying that superposition, creation of superposition gives rise to conscious experience. Just opposite to what Roger Penrose has said. Roger Penrose has said that collapse of wave function give rise to conscious experience. But they are just opposite of that, and they are trying to explore this area. So it's a very new field. 2-3 years back, more people are taking interest in this area. So what I'm saying that if we identify a conscious experience with unobservable quantum information, it allows us for application of quantum information theorems to resolve possible paradoxes created by the inner privacy of conscious experience. So it may help. I'm not saying that it may explain, but it might help people to explore this area also. There is a lot of potential in this area. So I say that conscious experience are quantum information. I'm just proposing this. So if a conscious experience is based on quantum information, then how it works? What are the substrate on which this quantum information works? Because quantum information persons, quantum computers, those who are building, there are substrate on which this works. Similarly, in our brain, there are neurons, and in neurons there are microtubules, which Professor Roger Penrose, and Hameroff has said that this microtubules supports many phenomena, mental phenomena, or you can say quantum states. These microtubule supports because due to their coherence, and it might give us a clue about how to explain this conscious experience, our mental states. So in our brain, these type of microtubules are very much popular because in our brain there are you know amyloids. The amyloids are proteins which are responsible for Alzheimer disease. So many type of microtubules are there in our brain, and these are very, very small. The micron size is small. You cannot just see with your eyes. And they are such a system which supports this type of quantum states. So it is hypothesized that microtubules could maintain quantum states such as coherence and entanglement, effectively serving as substrate for qubits in our brain. And it can also access quantum communication network. Very important, because our brain might have quantum communication network also. Because if there are microtubules which support quantum systems, then there are millions of microtubules. So our brain could act as quantum communication network. And these qubits, in principle, encode process information in ways that are non-local, superposed, and highly integrated features. And these features are alive very much like a binding problem of consciousness. When we say binding problem, it says that all the conscious experience which is coming from my tongue, ears, eyes, all these are integrated into a single conscious experience. So this quantum network in our brain could integrate all this information and give us a single awareness. So this, if we think that if this microtubule support quantum systems, so then we can explain this. We can get the hint of explaining this binding problem also, binding problem of consciousness. So there are recent findings in this area. Just a year back, a person, Professor Kurian from Howard University, has said that these microtubules support this quantum phenomena, the superradiance. And these are the protein molecules called tryptophan networks, and they exhibit quantum superradiance and supports quantum states. And the most important is that they maintain this thing at physiological temperatures. Previously, people used to think that in the brain, the temperature is very high. How these quantum states would prevail at that high temperature? Because for a quantum system to prevail, you need very low temperature, but that's not the case. These proteins, recent finding has suggested that this type of microtubules, this type of protein networks can maintain quantum state at physiological temperatures. So that is very important. It's a very recent work, and has been highlighted in many places. So this tryptophan networks access optical fibers. So we know about optical fibers, they guide light. Similarly, in our brain, there could be a mechanism by which there are light guiding inside the brain, biophotons. And they could exhibit this type of quantum phenomena. So there are another work, just a year back, a Chinese group has wrote a paper in PRE where they have said that there is an entangled photon generation in our neurons, myelin sheath. In our neurons, there is a axons, and there is a myelin sheath, and this myelin sheath, there is a cavity which generates there is a bond, carbon hydrogen bond, which generates this entangled photon pairs. And these entangled photon pairs, and there are many photons such that they could give rise to this synchronity in neural activity. How this synchronization happened in our neurons, that is a mystery, but these type of findings have supported this thing, the role of quantum entanglement in synchronizing neural activity throughout the brain. So quantum network in brain, as I already told, that quantum information can be instantiated, manipulated, transmitted within and between neurons through microtubule-based qubit system. And in this model, neural computation integrates classical ionic and synaptic signaling with optical, electromagnetic, and quantum coherent dynamics. So previously, we used to think that, now also we used to think that our brain activity is simply based on chemical exchange of information. But now things are changing. People are believing that there might be some higher things going on inside our brain. It's just not like a synaptic communication system. It's just not like chemical messenger system, because this, if there is a chemical mechanism, then there is a limit to the speed. It takes time to travel. But if we consider photons there, if we consider light-based communication network in our brain, then things will be instantaneous, because light travels at very high speed. So things are changing, and there are many things to be revealed. So there are biophotons inside our brain uh, that we need to detect it, and the role of their in information processing. So these provide a multi-layered substrate capable of supporting the qubits and complex and unified feature of cognition. So if there is a qubits involved in that, then that is definitely an unobservable. We cannot observe them. And it might support some feature of cognition. And that is a thing of research. We need to go more deep inside this to understand. So my conclusion slide, my important thing which I have started, that is our conscious experience are conserved or not, because we have already learned about the experience, the conservation of energy, conservation of mass, conservation of momentum. But we have, proposed that our conscious experience also remains conserved. It never lost. It always remains. Whatever we have experienced in our childhood, it is there, but it is buried inside some of the deepest layers. It is, if you trigger it, it will come out. So conservation of quantum information. Yeah, before going that, I will try to explain that in quantum information theory also, there is a conservation law. There is a theorem called no hiding theorem, which says that quantum information is never lost. It moves from one system to another system. It remains there. As Professor Arunpati also have told in his that day discussion. And there is a universe, there is a system. And if information from a system is lost because of some process like decoherence or randomization, it will remain in the universe. It will not go out of the universe. It will remain in the universe, maintaining its identity. The information will be there. So that is very important thing, which also moved me personally, and I tried to connect it with the conscious experience. So this theorem has been already been experimentally tested uh, by Samalji. She was IISER student. So this no hiding theorem, it says that information, if vanished from one system, it goes to another system, and it is not truly lost. And by suitable unitary transformation, the information residing in the environment, the information which has gone out, if we perform some unitary operation, it can be restored to the original form. So there is a process by which we can retrieve that information from other system which has gone to other place. And this behavior contrasts sharply with the classical information, which can be irreversibly lost through erasure. The classical information is lost, but quantum information, there is a process by which we can retrieve it. So this no hiding theorem suggests us that this conscious experience transit into ancilla qubits. If our brain is acting like a quantum network, photonic network, then these qubits can also go to some other place, some other ancilla qubits, but it is not lost. For example, in our psychology, we say that there is subconscious mind and conscious mind. So whatever we experience, it goes into some of the deepest level of our consciousness, subconscious mind. So similarly, there could be some ancilla qubits where these experiences go and reside. And when we recall our memory, recalling memory is very much like a retrieval of quantum information from these ancilla qubits. When we focus our awareness, then some of the information retrieves, right? So in this view, recalling a conscious experience involves bringing previously experienced thoughts, perceptions, or memories back into awareness. So there are many things which have been buried. When we recall it, it comes out. And it is essentially a reverse process where information stored in the ancilla qubits is reactivated into conscious cognition. So, so this perspective also explains why forgotten memories can resurface sometimes during sleep, deep emotion, brain injury, psychedelics, or meditation, suggesting that the conscious experience is not lost, but conserved and remains accessible. So for example, if sometimes we hear, when we put a headphone and hear some music, that music reminds us of our childhood days, because at that time also we have heard this music. So music or some other methods trigger this type of information to come out on the surface level, because they are buried at the deepest level. So when we trigger it, for example, when we go to some other places which we have visited in our childhood, that all these memories come out, retrieve. So what is the form of that memory? What is the form of that conscious experience? That we need to think about it, then we need to systematically study about it. A lot of scope is there. So yeah, so and it's my undergoing work. I'm doing some work on quantum consciousness and volatile quantum information, because there is other thing which is called volatile quantum information. That information remains even outside the system. It never lost and it remains outside the system. So how could it be connected with the quantum consciousness? And I'm doing some collaborative works, Professor Arunpati. So with this summary, I'm like to tell that there are two aspects of reality I already explained. And this conscious experience cannot be explained by classical physics due to its unobservability and uncommunicability. And quantum information theory may explain the inner experiences. And lastly, conservation of experience can be one of the possibility based on quantum information theorem. So with this, I would like to thanks all the people. Thank you.
Result of balance between decoherence in microtubules, as suggested by Penrose and others, and superposition, as the recent findings suggest.
It is just an hypothesis proposal. It's not been experimentally been verified. So
Okay.
people are trying.
Okay. The next question is, you said that conscious information is never lost, that is buried somewhere in the brain and can be reactivated. So how do you propose to reactivate early childhood memories of a person?
Yeah, I already told that there are many methods, by music, by meditation also. So there are many methods, and even sometimes while while you bathing, when you bath and sometimes do some different activities, things come out. So there is no general principle, but yeah, there could be many different depending on the subject, depending on the person, what type of process triggers him. Similar, sometimes you see is some people have the fear of water, right? What that fear is. Some people have the fear of confinement. Because when you go into confinement or touch water, that memories come out. It recalls. So depends on person.
I have personal question. Is
Yes,
there
sir.
any difference between experience and conscious experience?
There are conscious experience are experiential experience. It will always be related to some some life stuff, right? Conscious and subconscious experiences may be different, but experience, when you say that, you need to be general about what you mean.
Any other questions? Yes.
Yes, sir.
Hariraj sir has question.
I have three questions for you. First one, from this quantum information point of view, how would you characterize self-awareness, which is supposed to be the hallmark of consciousness?
Yeah, because that is also I'm trying, because self-awareness involves free will. If we have self-awareness, then we can take decisions. But do quantum information, if we build a system based on quantum information, can it take decisions? So in that case, I'm also doing some work on agency. Like, should we invoke some agency there who has that? So there is but it can act as a bridge between both of them. It is not, I'm not proposing that this concept experience is, it's self-aware, but it can act as a bridge between, can be subtler bridge between both of them.
My second question is, are you implying that there is no such thing as short-term memory? Because you are saying everything is conserved. Would psychologists agree with that?
I need to talk to them, because yeah, it's a very nice question. I will definitely do that, because short-term memory means you are saying that it goes out like sometimes. So it might be reside somewhere, because whatever we are doing, whatever we are experiencing, I think there is a place. It's not like it goes and lost. There is a place where it can be retained. In I need to explore more about it, because where it is stored, where are the memories stored? That is the good question. Is it storing in the only tribunes, or there is a network of? So we need to explore more, sir.
And my third question is, when there is brain damage, let's say due to an accident, what do you say about your conservation principle?
Yeah, there is a thing called neuroplasticity. People say that when brain are damaged, brain has this neuroplasticity. It maintains that information. Because I have seen some of the example, Carlos was a person who has, 50% his brain was but still his cognitive abilities are still intact. How that is happening? Because maybe neuroplasticity are playing the role there at brain level, memory level, where it is stored and how that thing I need to explore, sir.
Thank you.
Thank you, sir.
One more question here. You seem to suggest a physical origin of consciousness. In this case, what steps can we take to make a conscious AI?
Yeah, that's what I was saying, that there are companies who are trying to, use quantum information to create some conscious AI. But let's see the process, how long it goes, and what we can complement. It's not like we are going to create AI, but we can conscious AI, but we can understand, we can reverse engineer and understand how the thing could be made to move towards that. It could either we are, if we are not able to make a conscious AI, we can understand the process. We can explore our own inner self, right?